Hello everyone, my name is Zion De Castro and today I'll be talking about Object-Oriented Programming, otherwise known as OOP. Some of you may be asking, what is Object-Oriented Programming? Well, if that's what you're wondering, you're in the correct place. And hopefully by the end of this video, you'll have a firm understanding of what Object-Oriented Programming is, what the four pillars of it are, and why it was created. So let's get it started. So prior to object-oriented programming, there is procedural programming. And the two main characteristics of it is that it was divided into functions and it was very top-down. And now we'll go even deeper into what procedural programming was and is. So here we have a visual representation of what it kind of is like behind the scenes of procedural programming. So in this example, we have two functions, function 1 and function 2. And both of these are kind of mutually exclusive because within procedural programming, the classes are basically like functions. So each function can't call another one. So the drawback of this is that if you had to write another function that was similar to another one, you'd have to copy and paste. And what's really interesting and a drawback of this is that if you have many similar functions and you try to change one of them, the rest of your code probably won't work because if you fixed a bug in another and you didn't trickle that down into your other functions, that could really cause for code that it doesn't work and doesn't compile. So that's really a big drawback of procedural programming. And it is a very top-down from the sense that each function is kind of like mutually exclusive from each other and they hold their own data. So to remedy this problem of what we call like spaghetti code, which is when multiple functions kind of are connected in a sense through like copy and pasting, where if one of the functions is messed up, it's really hard to find out where the problem was, and it's hard to really track that down. So to remedy that, we have object-oriented programming. And the two main components of that is that it's divided into objects and it is a bottom-up approach. And it will do a visual representation of that now. So here we see three various functions. Each of them contain their own set of data, and we put these functions and classify them as quote-unquote classes. And these classes are able to call upon another class to utilize some of their functionality. And this is really good and helps mitigate spaghetti code per se because you'll be able to utilize different blocks or classes of code and speed up kind of your development process and also be able to track errors easily. And this is bottom up in the sense that each of these classes has a purpose and you can reuse the functionality of those to aid in whatever other classes that you're creating. So, in object-oriented programming, there are four main pillars: abstraction, encapsulation, polymorphism, and inheritance. And now we'll go a little bit more into each of these. So, abstraction. In essence, it is using simple things to represent complexity. So, for example, variables and object classes can represent more complex code. Here, in this example, the object class that we're using is animal, which is actually an abstract class. So animals, if you're looking at this like a general sense, there's a lot of complexity that comes into it. But if you just have one animal class with certain variables and things that are set standard for like most animals, this is a more simple way to represent what's complex. And as we see here, there's the abstract class of animal. Then we also have subclasses of cat and dog, which are also animals. So it's an easier way to organize your code and make sure that you understand what goes into each method and just a better way of tracking. Second is encapsulation. Encapsulation is keeping fields within a class private and providing access to them via public methods. So this is kind of used as a protective barrier to keep our code safe. So to the right is a visual representation. I made it look like a capsule, but it's really a class. And within the class, you can choose for it to be private or public, and you can also choose to have the variables within like your method and class to be private or public. This helps for privacy and making sure that you are protected or your code is protected. Conversely, within procedural programming, there are no private like variables or like methods. So this is a great way for you to grant permission access to certain things and protect them through being in various classes. Polymorphism. So polymorphism is essentially using the same word to mean different things in various contexts. So here we have a superclass of shape, which has a draw method. And then the subclasses of that are circle, triangle, and square. Each of these subclasses, however, have their own draw methods. So because shape uses a draw method, that doesn't mean that the circle method has to utilize the same one. If the circle method here did not create its new draw method, then it could use its superclasses, which is shape's draw method. But because it made its own, kind of like overwrite it, and you're able to use the draw functionality within circle if you're in the circle class, and vice versa if you're in the triangle class or square class. Inheritance. So inheritance essentially lets programmers create new classes that share attributes of existing classes. And you can build upon previous work without reinventing the wheel. As we see here, Java and C++ are object-oriented languages, which also go under the umbrella of programming languages. Conversely, Pascal and C are procedural programming languages, and they go under the umbrella class of programming languages. So this is just a short snippet to see how inheritance really works within object-oriented programming. Thank you for listening, and I hope you learned something today.